All right, let's dive right in. Today, we are talking about how the absolute explosion of data has completely changed the game for cybersecurity. It's created this whole new battlefield with new kinds of threats, and it's forcing us to come up with entirely new ways to fight back.
So, to really get a handle on the scale we're dealing with, let's start with this one kind of staggering number. Back in 2011, a study predicted that 90% of all the data we'd create over the next decade will be what's called unstructured. And you know what? They were spot on, and that prediction really set the stage for the data deluge we are all living in right now.
So, what even is this massive wave of unstructured data? Getting our heads around this is pretty crucial because it's where both the problem and, as we'll see, the solution really begin.
Okay, so to put it simply, unstructured data is all the stuff that just doesn't fit nicely into a neat little box. Think of a traditional database as a spreadsheet with perfect rows and columns. Well, this stuff is the opposite. It's messy, it's chaotic, it's always changing, and frankly, the older technologies just weren't built to handle its sheer scale or complexity.
And where's it all coming from? Oh, just about everywhere. We're talking about every single email you send, all your social media posts, videos, click streams, not to mention the constant flood of data from machine logs and all those Internet of Things sensors. It's basically the digital exhaust of our modern world, the byproduct of everything we do online.
Now, to try and wrangle all this chaos, we needed a completely new kind of technology. And that's where NoSQL databases came in. Things like MongoDB and Firebase. They were designed from the ground up to be super flexible and scalable, specifically so they could handle the messy, always changing nature of this new data landscape.
And believe me, this ecosystem is massive. You've got powerhouses like Amazon's DynamoDB and the open-source Apache HBase that are huge players, really forming the backbone of this whole big data revolution. This isn't some niche field anymore. This is the new standard for how we manage data. But here's the catch. While our ability to store all this new data was evolving like crazy, our methods for actually securing it were stuck in the past. And that created these massive blind spots for traditional security. For decades, cybersecurity kind of worked like a bouncer at a club with a list of known troublemakers. It used what are called signatures, basically unique fingerprints of known viruses and malware. If a file matched a signature on the list, it got blocked. It was simple, and for a while, it was pretty effective.
So, what happens when the troublemaker isn't on the list? This quote really nails the fundamental flaw, right? Signature-based security is always, by definition, one step behind. It's completely blind to new and never-before-seen attacks.
And this very weakness, well, it created the perfect hunting ground for a new and much more dangerous kind of predator, the advanced persistent threat, or as you'll often hear called, the APT.
Now, an APT isn't your typical smash-and-grab attack. No, think of it more like a spy. It's a stealthy attacker that slips into a network and just stays there, sometimes for months or even years, quietly watching and stealing data without anyone having a clue. The name itself tells you exactly why these things are so dangerous. It's advanced because it uses custom tools that won't match any of those known signatures. It's persistent, meaning it's in it for the long haul, not just a one-time hit. And it's incredibly stealthy, using all sorts of clever tricks to hide in plain sight.
So, one of the main tricks they use to stay hidden is something called obfuscation. On the left, you can see a malicious URL. That's an easy catch for a traditional firewall. But on the right, it's been encoded into what just looks like a random jumble of characters. Now, the computer can still read it just fine, but the security system? Totally fooled.
And that advanced part? It's not science fiction. This single line of code here, using a widely available tool called Metasploit, can generate a brand new, custom piece of malware. Attackers don't need some massive state-sponsored budget. The tools to create these never-before-seen threats are literally out there for anyone to use.
Okay, so that sounds pretty bleak, right? But this is where the whole story starts to shift, because it turns out that the very same big data that created this problem, well, it also holds the key to the solution. We can actually turn the tables on them using analytics.
Which brings us to the really crucial question. I mean, if you can't trust your list of known bad guys anymore, how in the world do you fight an enemy you can't even see?
The answer is you stop looking for the attacker themselves, and you start looking for their shadow, for the subtle changes in behavior and all the little anomalies they create just by being inside your network. And that is the core idea behind big data security analytics. Instead of looking for known bads, you collect all the data you can. Network logs, user activity,
everything to build a really detailed baseline of what normal looks like. And then you hunt for anything that deviates from that normal.
And to do this, you feed the system everything you can get your hands on. We're talking network traffic, logs of who's accessing what files, email patterns, even data from outside sources like threat intelligence feeds. The whole point is to create the richest, most detailed picture of your environment that you possibly can.
So what do these shadows actually look like? Well, analysts are hunting for things like, say, an employee's computer that suddenly tries to access the finance server for the very first time. Or maybe a huge chunk of data being moved to a strange location in the middle of the night. These are the little telltale signs that an APT might be at work.
But of course, this powerful new approach, it isn't a silver bullet. Because as you can probably guess, fighting data with data brings its own entirely new set of really complex challenges.
For starters, the data you're analyzing can be noisy or just plain wrong. The sheer complexity of modern networks is just mind-boggling. And then, of course, there are these huge privacy questions that come up when you start monitoring user behavior on this massive scale. And that's not even getting into the technical nightmare of trying to analyze data that's encrypted.
Which really leaves us with one final and really critical question. This whole new world of security requires levels of monitoring we've never seen before. So, as we build these systems to watch everything in the name of safety, we have to stop and ask ourselves, who is watching the watchers? Thanks so much for joining me for this explainer.